Guys, proof of Euler's theorem.
What was Euler's theorem again?
The intermediate version.
Yeah.
What was Euler's theorem again?
The something about phi theta phi.
Yeah, so let me just remind you.
How do you spell Euler?
See the irrelevance of him? How do you spell Euler? Okay, so define phi of n to be the number of integers between
I don't know how
1
to prove.
and n co-prime to n, yeah? Make sense?
How?
A to that thing is 1.
How?
So actually, do you know that these are exactly all the numbers which have an inverse mod n?
Oh,
Yes?
wait.
What?
Wait, I might. No, oh.
Surely.
So if let A be co-prime to n,
Wait, I think I.
then Euler's theorem says A to the phi of n
Oh yeah.
is equal to 1 mod n.
No.
Yes, we did this in Gauss.
Did this in Gauss, the proof?
Not the proof, but just using it.
Just using it.
Why
Oh.
did you do
Like
it?
prove that like x to the something equals something whatever.
I don't remember doing that in Gauss.
So we proved this in the junior class from Fermat's theorem and binomial coefficients of primes.
Why are they the junior class? Why aren't we the junior?
Why are we
just
not
purely
small?
because of age.
I want to be small.
Not intelligent.
Yeah. For some, it could be.
Because that's about their height.
Yeah.
Can I be small?
I'm sorry.
Okay. Alright, so the reason why this is maybe more intermediate, we can use some functions ideas. Do you know what a function is?
Yes.
Guys, you
Alright.
know not making that out.
Do you know what a bijection is?
Yeah.
Bijection,
Bijection.
Yes. and
is that where every input has
So like a bijection, so you have two
everything
sets, right?
is associated with everything else.
If you have two sets,
Is it
and
the
they're in
two sets-
bijection,
Is it the two sets that have the same have
Yeah.
the same number of things and each one goes
Yeah,
to a different one?
they have the same number of things, and not only do they have the same number of things, the function pairs them up.
Oh.
So the function is the bijection, it pairs the things up. So it gives you one way to realize that they have the same number of things.
Wait, so can you like make an inverse function?
Yeah, you just go the other way, right? So like if you just have 1, 2, 3, right? A, B, C. These are in bijection. Oh, bijections, I don't know if the word bijection, but this idea is in the school syllabus, I'm pretty sure. Okay, inverse function is in the school syllabus. So look, you have one function, you can do like f of 1 equals A, right? F of 2 equals B, f of 3 equals C, right? And then you can have g of A equals 1, g of B equals 2, g of C equals 3, yeah? So these sets are in bijection. The bijection is given by f and g, right? And the inverses to each other. So f goes that way, g goes the other way. F composed with g is the identity. Well, is the identity. G composed with f is the identity. Yeah. All this sounds pretty standard.
Seems like
Yeah. Okay. So here's this cool thing. So I claim that if A is so if B is co-prime to n, yeah? Yeah? If B is co-prime to n, then there's a reciprocal of B mod n. That make sense? There exists like a C such that C times B is equal to 1 mod n. And obviously B times C is the same as C times B. That makes sense? Can you prove that?
Is it
Oh, okay. So this is something I probably did maybe before you came. Okay, so there's this thing called Bezout's lemma, yeah? Shout out to holiday program number 1.
I do not know how
I feel
to
like-
prove it. Because I forgot.
It's really basic. So it's like if you have like What letters should I use? Maybe like A x plus by, yeah, equals C is like an equation, yeah.
Yes.
As long as the GCD of A and B divides C, yeah. So GCD of A and B divides C, then there's a solution to this equation. There exists x and y integers satisfying. So these are all integers, yeah?
Indeed.
Remember this? We actually proved this as well.
I remember this.
Yeah.
To some extent.
Okay. So the point is if B and N are co-prime, yeah? If B and N are co-prime, I think you can do something like this. You can set A and B to be B and N. Let's see if that works. The bx plus ny equals 1. Yeah? Does that make sense?
No.
Comprehende? Yeah, so bx plus ny equals 1, yeah? Which exactly means if you take this mod n, right, it means bx equals 1 mod n. So in this case, x is equal to c, right?
Yeah.
Yeah.
And this
We
is
did
the
it.
code.
So they all have inverses, yeah? So in particular, this A has an inverse mod n, yeah? Okay. How does that make this work? Well, consider this function, okay? So you got z mod n, z, going to z mod nz, yeah? Let's call this function f. What does this function do, yeah? It takes some number like k, yeah?
There we go.
And then maps it to a times k. Understands you? See what that function does? It just scales by this a. Yeah?
Yep.
Okay, so my claim is this gives you a bijection. A bijection from the two sets.
Yeah.
Obviously the two sets are the same size, right? Yeah? But this gives you a way of sort of scrambling the sets and corresponding them to each other. Does that make sense? What I'm saying? So if you want to see it in terms of just one function, one way of saying that is no two things go to the same thing, right? And everything here can be reached using this thing. Okay? That's like injective, surjective. Does that make sense? Okay. But to explicitly realize like the bijection that goes both ways, you can also just figure out what the inverse function is. Yeah? Can you see what the inverse function is?
Okay,
Divide.
over it.
Yeah, the inverse function is just divide by a, right? So that actually shows you everything will is of the form ak. Alright, where am I going with this? Okay, so if I restricted myself, instead of looking at all the things mod n, right? I just did the ones which had inverses mod n. Let me call it with a cross. Yeah? Can you see this is still a bijection? So now it's not just all the numbers mod n, there's not n of them anymore. Now we're talking about the numbers which are co-prime to n. Yeah? So now there's not n of them, but how many of them are there?
Fine.
5n, yeah? So now there's a bijection between two things having a size 5n. Make sense? Okay. So what if I times everything in here together? Yeah? So let's call them the product, yeah, of b's as b runs through everything in this invertible set, yeah? So if I times them all together, right? Yeah, it should be the same as if I times them all together multiplied by a, right?
A to
Does that make sense?
wait, isn't that just a to the 5?
Yeah, good. You're looking ahead. But you see why this is true?
Yeah.
Because this is a bijection. This just reorders all the b's, right? But you're timing them all together anyway, yeah?
Yeah.
So they're equal, yeah?
Yeah.
But then, and then, as George was saying, there's how many a's are coming out at the front? There's five a's, right? So you get this is equal to a to the 5n product b. Yeah.
And then that's okay.
No clue. All right. Thanks.
I'm going to find by science by that.
What?
Take a bullet.
Yeah. Take a mod in. Yeah.
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 What's
Yes, indeed.
what's
So pi is the product of all of them. Yeah. But the point is, it doesn't matter what it is. It's the same on both sides, right?
Yeah.
So you can cancel them.
All.
Because these are all invertible now, right? So you can cancel them all. Yeah? And what do you get there when you cancel them?
A equals 1, A to the 5.
Yeah.
one?
Michael is big brain.
Nice.
This is like, well, this is what you call the group theory proof. And obviously the Fermat's little theorem is a consequence. You let n be a prime, yeah? Whereas the other proof was like we built it up. Yeah.